Hi dear students, welcome to my channel. This video is useful for 8th standard onwards. Keep watching. Okay students, in this video we discuss friction. Okay, what is friction? Why friction come into the picture? We'll discuss with some examples. I am taking two objects. One is book, another is Vicks VapoRub. Okay, I am keeping this Vicks VapoRub on this book like this. Okay, now the surface of this Vicks VapoRub and surface of this book are in contact. Agree? Because of these two surfaces are in contact, there is some electrical interaction of atoms or molecules of this Vicks VapoRub with the atoms and molecules of this book. Means simply the atoms and molecules of this surface and atoms and molecules of this surface, there will be some electrical interaction. Because of that, friction come into the picture. Okay. Now we will discuss further. There are some forces come into the picture because of the friction. Okay. There are two types of forces. One force is the force of static friction. Another one is the force of kinetic friction. What is this? I will explain clearly with this example. Now you see here, same. One book is there, one object, one Vicks VapoRub is there. This is another object. Now I am applying a force on this Vicks VapoRub. Okay. So I am applying some force, but it is not moving. Because friction is there, no? So it will oppose the external force. This is external force, no? So frictional force opposes this external force, means opposite direction. Along this direction, the frictional force come into the picture. So the force that is opposing the external force, when these two are in stationary, means these both are at rest, this is not moving, that time that force of friction is called the force of static friction. Because when these two objects are at rest, you are applying an external force on this, still it is not moving, that time one force is opposing this external force along this direction, that force is called force of static friction. Okay. Now force of kinetic friction. When that will come into the picture, I am applying force, I am applying more force. The magnitude is more. What happened? After some magnitude, it started moving. This time, when it is moving, no. It is moving like this, no. When this object is moving on another object, that time one force opposes this external force along this direction. Okay. This force is called kinetic friction. Simply, I will tell you, when two objects are in relative motion means it is moving along this direction, means one force applies along this direction, means force comes along the opposite direction. Suppose it is moving along this direction, means what? One force comes like this, because it is moving like this, means opposite direction force comes. That is called force of kinetic friction. Okay. You watch forward, you will understand very clearly. This is force of friction. Class number 54. Forces of friction we will discuss now. When a body is in motion, either on a surface or in a viscous medium, such as air or water, there is resistance to the motion. Because the body interacts with its surroundings. Such resistance called as force of friction. Simply this body which is moving in another medium, no, or it may be moving on another object, it interacts with the surroundings. That is the reason these forces of friction are coming. Okay? Importance of forces of friction we will discuss. The first one is they allow us to walk. For walking also friction is required. Otherwise you will slip down, you will trip. Second one, they allow us to run also. For running and walking friction is required. Third one, they are required to the motion of a wheeled vehicles. For cycle, motorcycle, car, everybody has wheel, no? Everything is wheel. For the motion of wheel also the friction is required. Okay? Now we will discuss some forces. The frictional force. I am representing frictional force with a letter small f. Okay? The force of static friction, Fs, subscript s, no, that is static. Okay? See one object here, mass m. It is on the rough surface. This is lying on the rough surface. I am applying external force F along this direction, that is right side. But it is not moving because of the force of static friction that is opposing this capital F. It is along this direction. Just because you are applying force F, then only this force of static friction is coming. Be careful what I am telling. If you don't apply this force, no, this Fs will not come. When you are applying external force only, this force of static friction comes exactly opposite to the applied force. Simply free body diagram I am writing. This is mass m, downward force is mg, upward is normal force. So opposite this n equal to mg, that we did not discuss now. But right side, the force F, applied force is there, no? The object is not moving because this Fs, the force of static friction is coming. It is opposing this capital F along this direction. So this object is at rest, no? So this applied force must be equal to force of static friction. So Fs is equal to F. You got it now? The first one, if we increase the magnitude of F, that is applied force, then the magnitude of Fs, force of static friction, also increases until the object is at rest. This is important point. Okay? Another one, just before the object starts to move, then force of static friction is maximum. Okay? Here I am writing Fs max means maximum force of static friction. Okay? Now third one, when F, this is external force, exceeds Fs maximum, this is maximum force of static friction, the object accelerates to the right. You have seen the figure, no? So applied force is along the right. That is why the object accelerates to the right. Now we will do one experiment. What is static region? What is kinetic region? Very simple experiment. Say I am taking one book. This is one object. This is another object, that is Vicks vapor. Now this book is horizontal. So this Vicks vapor is not moving. Means this object is not moving. Now what I do, I will slowly tilt it. I will tilt it. I am tilting. What happens? After some angle, it started moving. You see, it is moving. Getting or not? When I am tilting this book like this Vicks vapor it started moving. You see, after some time, So from horizontal to up to some angle, up to some extent, you see I'm increasing the angle now. So this region, that wicks is not moving. That wicks vapor up is not moving. It's not moving, not moving, not moving. Now started moving. This region from horizontal to up to some angle, this is not moving. No, this is called static region. Okay. After that, started moving. This is kinetic region. Means when you are applying force up to the object is not moving, that region is called static region. Once it started moving, no, that region is called kinetic region. Okay. So what is happening when you are tilting this? Simply the gravitational force is downward, but that is prevented by normal force upward. But when you are tilting, one force comes along this direction, mg sin theta. So theta increasing, sin theta increases, no? So along this direction force is increasing. As long as the force reaches the maximum static frictional force, this object will not move. After that, what happens? It starts moving. Okay. So you understand what is static region and what is kinetic region. Okay. You watch forward, you will understand very clearly. I have represented this concept with graphical representation. Okay. On x-axis, I am applying the external force. On y-axis, how the frictional force is coming. Okay. You watch the graph, you will understand very clearly. The fourth point is this. Once the object is in motion, the retarding frictional force is less than the maximum force of static friction. This is carefully observe what I am telling. Once the object is in motion, know that kinetic friction come into the picture. The force of kinetic friction is less than force of static friction, what is telling. Okay. Already I have discussed, no, the static region and kinetic region. You see this graph. This is x-axis. On this x-axis, applied force is there. So on the x-axis, applied force F is there. On y-axis, frictional force is coming. So as long as you are increasing the force like this, no? Suppose you are increasing 1 Newton. So corresponding 1 Newton static frictional force comes. You increase applied force. So object is at rest only. So up to here, you are increasing the force up to here. The frictional force, the force of static friction also increasing up to maximum value. So when maximum value reached here, this is the maximum force of static friction. So from here to here, you are applying force, no? The object is rest. That is why this region is called static region. After this, what happens? Immediately, it started moving. So this force, this maximum force of static friction decreases like this. So after some significant change, decrease in the force of kinetic friction, it will maintain. Means this region, from here onwards, the object is moving. The force of kinetic friction is this. This is Fk equal to mu k into n. This I will discuss later. This is force of kinetic friction. This value is less than this force of maximum force of static friction. We will do some problems. You will understand very clearly. You see here, object here, you are applying the external force. F is bigger. It is bigger, larger. So Fk, the kinetic friction opposing this force. But this capital F applied force is more than this. That is why this is moving like this along this direction. So motion means this particle is in the motion. It is moving along this direction. So there is kinetic frictional force opposite direction, that is along this direction. Okay, this Fk is less than Fs maximum. I hope you understand. In the next video, we will solve some problems. You will understand very clearly. Okay? Thanks for watching. Please like this video, share this video and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos. Till next video, bye bye, tata.